taking a look at advancing autonomous driving, the role of high-resolution wheel speed sensors to drive this conversation, pun intended. I have two great guests to introduce you to today. Palani Thanigachalam is Senior Technical Program Engineer for TE Connectivity, and Todd Eckhardt is Senior Principal Systems Architect for TE Connectivity. Thank you both for being with me today.
Thank you, Michelle. Nice to meet you.
Hi, Michelle. Nice to meet you.
Nice to meet both of you. And as I said, we have a lot to talk about today with advancing autonomous driving. But before we kind of dive into the Q&A, I'd love to have people learn a little bit more about each of you. Todd, starting with you, can you give us a brief bio, please?
Yes. My name is Todd Eckhardt. I'm a system architect at TE Connectivity Sensors Business Unit. And my main responsibility is for brake and safety applications in automotive and commercial vehicles. A little bit about my history. So I've been in industrial, medical, and automotive sensor industry for 25 years, mainly in technical, but also in product management and marketing roles.
And what about you, Palani?
Yeah. My name is Palani. I'm a Senior Technical Program Manager in TE Connectivity Sensor Business Unit, responsible for driving project execution and technical oversight for new product development. I have been in the industrial and automotive sensor industry for more than 20 years in a variety of new product development and technical program management roles.
So clearly both of you know what you're talking about when it comes to the topic at hand. So I want to get right to what we're about to talk about today. With the rapid advancements in smarter technologies, the automotive industry has really seen significant changes in vehicle design and capabilities. Can you share your thoughts on how these advancements have impacted the overall design of vehicle safety systems, and what trends do you see emerging today?
Yeah, good question, Michelle, to lead off. It really is incredible the amount of information that the vehicles are using to improve safety, comfort, and convenience. A lot of cameras, along with other sensing technologies, are really reducing and even eliminating the accidents due to distracted driving and blind spots and accidental lane departures, among others. I think you see in your vehicle these days, I think almost every vehicle coming out on the market today has some type of capability, whether it's alerting the driver to a potential issue in the blind spots or lane departure, or even staying in the lane or emergency braking.
So with all of these changes, vehicles are obviously becoming more complex, right? A lot of moving parts here. How has this affected how different systems in the vehicle, like braking and steering, work together?
Yeah, so one of the future goals of the OEMs is full integration of all the chassis systems. And that's going to really improve the driving performance and the safety in the vehicles, and also lead to the future for autonomous driving. Ultimately, this requires that the steering, the braking, and suspension systems all communicate and work together as one system. And the fusion brings a number of challenges into the industry, and they're working on trying to solve those problems. More data and various new sensors and cameras in the vehicle are all going to require more computing power in order to work together and to help make decisions on what the vehicle needs to do and how they're going to keep the occupants safe. And all of that decision making and countermeasure analysis needs to be executed properly. So the sensors are going to be inputs into the system, and they're also going to be inputs into verifying that the system is working correctly.
So let's talk more about those sensors, because as you said, there's so much more data. There's so many things to kind of keep track of. How has the need for sensors technology changed with all of this?
Yeah, so on the path towards all of this chassis systems, safety fusion, sensors are going to provide data to support decision making across multiple systems. Actually, we already have a lot of this today. So we're going to talk about advanced high resolution wheel speed. And in today's wheel speed, those sensors are actually being used across multiple systems. They're initially introduced for anti-lock braking and electronic stability control, but they're also supporting adaptive cruise control and indirect TPMS. As we go into the future, wheel speed, among other sensors, the data is going to be shared into even more systems and become even more critical for the control of those systems and verification to make sure everything's working correctly.
So there is one sensor in particular that I would like to talk about now, TE Connectivity's new high resolution wheel speed sensor. From my understanding, this product is a significant step forward for the industry. Can you tell us what this product is? Why is it so important?
Yeah. So the standard wheel speed sensor is also known as ABS sensor, works by detecting the rotational speed of your magnetic encoder, which has got a set of magnetic pole pairs. For each pole pairs, typically two pulses are generated. These pulses are sent to a vehicle electronic control unit, which helps to determine position of the wheel. We have launched high resolution wheel speed sensor, which can generate up to 4 times more pulse than a standard wheel speed sensor, what is there in the market. Because of the high amount of data, it can provide more improvement in terms of vehicle position, vehicle motion controls, better dynamics, and improved comfort and safety.
So definitely some good results that you're seeing right there. Let's talk about how we get those results. How does this new sensor work? What makes it special?
Yeah. So this new technology with the advanced algorithm helps to measure the additional pulse between the one magnetic pair poles. So the technology also helps to provide robust air gap variations. This provides high resolution data that can be that can be used for accurate distance measurement of the wheel positions. Todd, you wanted to add more points here?
Yeah, so I think there's a lot of advantages to the new product. So historically, you're getting about 2 centimeters of position on the tire, and now you're getting about half a centimeter. That is going to give a lot of tighter control to things like automated motion path planning in parking lot situations. And that's going to help reduce the risk of minor contact or near misses during parking lot maneuvers. There's also wheel direction on every pulse. So now when you're on a hill and you need to move from braking to acceleration, a tiny movement in reverse is going to be detected by the vehicle, and the vehicle can then keep itself stationary on the hill, so you're not rolling backwards at all, and it'll be completely imperceptible to the driver.
Yeah, that's correct, Todd. So, especially high resolution wheel speed sensor can significantly enhance the ADAS functions, which is called Advanced Driver Assistance System. So, by providing more precise and reliable data, which is crucial for effective operations. So, some of these benefits includes accurate anti-lock braking systems, enhanced traction control and stability, improved adaptive cruise controls, precise vehicle dynamic controls. So, some of these benefits really will helpful. Enhanced autonomous driving capabilities will really one of the another big benefit. So, for semi-autonomous to a fully autonomous driving, high resolution wheel speed sensors provide very crucial data for understanding the vehicle motion and dynamics. And this helps overall accuracy and safety of the autonomous system.
Yeah, I mean, clearly some benefits there. And I have to say, you got my attention with parking lots because I think we've all been there, right? We've all had those struggles in those parking lot situations. So let's talk about the unique features and benefits of this new sensor compared to what's already out there, because there are other sensors on the market. But why do these features that this particular sensor has matter so much?
Yeah. So we all know that TE has got 20 years of experience in manufacturing wheel speed sensor. So we understand these sensors are mounted in a wheel hub where the sensor is exposed to very harsh working conditions such as high humidity, rainwater, vibration, and mechanical shocks. So we have developed a more robust overmolding package for the electronic encapsulation using advanced plastic resins that can offer improved sealing performance for the IC integrated circuit. So this innovation helps to reduce risk of IC failure due to water ingress. Additionally, the sensor design and the material provides higher mechanical strength that can withstand very harsh working conditions. The product are fully validated using reliability engineering technology. We subjected the sensors to a very high harsh working conditions like accelerated life test and extensive product validations.
It's clear that a lot of work has gone into developing this sensor and make it better. Can you share any information on how TE manufactures the product and ensures consistency in the quality, which is so important, even at large volumes needed in the automotive industry?
Yeah, so we produce these sensors using fully automated production line that is completely compliant to the VDA 6.03 process standard. We also do regular audits to ensure that the line is compliant to this VDA 6.3. We have established all the process control parameters with 100% traceability for every sensor we manufacture. We monitor injection parameters and all the process controls recorded completely 100%. We also established fully automated vision systems for inspection. Also enables these features are enables high volume production and consistent quality.
So the build and design cars are fairly different between manufacturers. How does TE work with customers and help them integrate this new technology into their unique designs?
Yeah. So as I told you, we have long experience in manufacturing wheel speed sensors. Also, we supply such sensors to many OEMs. We have even more experience in manufacturing automotive connectors. We have state-of-art of lab, test labs, and the evaluation facilities to support variety of customers. TE connectivity can customize the sensor design based on the customer requirement. We also provide various configurations, size, forms, and quality requirement based on the OEM's requirement. So the quality organization is fully trained and available to support functional safety concerns and requirement. We are always seeking inputs for future generation of the product, exploring new capabilities, and addressing functional safety requirements. Uh, so we can provide a fully integrated and reliable sensor and its connector solutions to the customers. We can offer samples for initial testing and evaluation as early as possible.
I heard two keywords, probably more than once through this: new and explore. I know you definitely said that, Palani, because there's so many new things happening coming on the market and technology moving so fast. There are new areas to explore very quickly as we're seeing where this technology can go. So, looking ahead, what new things will this sensor make possible for cars in the future?
Right. So Palani described what we have today. There is a lot coming in the future. Enhancing existing functionality, this is just the first step. The automotive industry and commercial vehicle industry, they're both continuously adopting and upgrading their sensory capability. And these more advanced capabilities support by-wire systems that can react fully autonomously. We have by-wire systems in the vehicle today, and it's going to increase in the vehicles. And OEMs see this as an opportunity to save costs, at the same time adding a lot of safety capability to the vehicle. Whether the autonomous function is occurring in a controlled environment, such as normal highway driving, or an emergency environment, such as evasive maneuvering, more data will be needed to ensure the vehicle is responding appropriately. Assuming all four wheels are still in contact with the road surface, wheel speed will be one of the measurements used as a critical input to chassis system controls today and in the future.
And what do you think the future of wheel speed sensors will look like?
Yeah, we can see faster data rates and even more accurate vehicle position as being highly valuable for the controls. High resolution wheel speed sensor available today is just that initial step towards fulfilling the needs by the control engineers. As the system requirements advance, the control engineers are going to start specifying the need for more and more data, and the wheel speed is going to have to evolve with that need.
So before we wrap up here, it's hard to believe that there could be something just as exciting as the wheel sensor that we're talking about, but TE is working on quite a few things right now. So what other exciting projects can you tell us about from TE Connectivity?
Yep. So the advancement, especially in autonomy and ADAS systems, continues to require new sensors and new capabilities of existing sensors. So in addition to the wheel speed sensor, we have the capability to supply a number of other sensors, either that we're developing or we have in production today. We currently supply pressure sensors for advanced braking systems, electro-hydraulic brake systems. We have position sensors for steering systems, rear axle and front axle steering. And we do humidity for camera lens defog and ingress detection for advanced autonomous systems. And looking towards the future of braking, we are developing force sensors to support the electromechanical brake systems and advanced suspension systems. And these are just a few of the developments at TE Connectivity.
I was going to say, we don't have enough time to go over everything that is exciting that you're working on at TE Connectivity, but a great start here today, of course, talking about advancing autonomous driving and the role of high resolution wheel speed sensors. And you've got a pretty special one there at TE. So great conversation. Enjoyed the discussion. Thank you so much, Todd and Palani, for sharing your insights on the high resolution wheel speed sensor and how it's really shaping the future of car safety. Appreciate you being here today. So thank you for your time.
Thank you, Michelle.
Thank you, Todd.
And I want to thank our listeners for tuning in. If you'd like to learn more about this technology and additional sensors, be sure to visit the high resolution wheel speed sensor product page on the TE.com website, where you can also reach out directly to a TE expert. Thanks so much for tuning in. I'm your host, Michelle Dawn Mooney. We hope to connect with you on another podcast soon.